Welcome back to the video lecture series for Introduction to Additive Programming using Scala. In the last video, we constructed a mutable doubly linked list, at least we think we did, but we haven't tested it yet. So in this video, I just want to run that same code through a series of tests, and indeed, we already have a set of tests for the singly linked list, and because the interface for these is the same, it makes sense to copy over those tests. So we'll test mutable DLL, make a class for that, close off the singly linked list, we'll copy over our imports and import the DLL. Copy, paste, and change the letter S to D in two different places. And I believe, why is this still giving me a warning here? Imported, it's permanently hidden by definition of class. Oh, I put that in the wrong place. Let's drag this down to test ADT. Okay, now we have the test in the test directory, and I should be able to run these tests, and if we're lucky, green bar, yay, it passed all these tests. One of the things that I promised while we were working on the singly linked list was to talk about how in some ways what we're writing here isn't quite ideal as far as fitting into the Scala libraries. We made it so that our type extends mutable buffer, but it's worth pointing out that this might not be doing exactly what we want. And so, just to show this, let's test filter. And let's add LST, insert all of a list of a bunch of numbers. And let's insert that at index 0. Now, I want to filter out only the odds of underscore modulo 2 is equal to 1. Okay. What is the type of odds? Now, because I did filter on the LST object, which is, are we not going to get the pop-ups here? Which is definitely a mutable DLL. One would expect that odds should also be a mutable DLL. Okay, it's not going to give me the pop-ups, but I can print line odds. Normally you do not put print statements in your unit tests. They aren't supposed to print anything. They are just supposed to give you a green bar or not green bar. But you can print if you want to. Note that it worked. It gave me 13579, but it didn't return the type of a mutable DLL. Instead, it went straight to an array buffer. So if you do the extends this way, well, it's easy, and it gives us the methods we want. Any methods that are creating new things are going to work in the way that buffer was written to create the default type that buffer creates. In the textbook, I go through an explanation of how you can change that so that it will return whatever type that you want. In our case, we want the singly linked list to return a singly linked list and doubly linked list to return a doubly linked list. So you can do that. let's see, 1, 3, 5, 7, 9, total of 5 elements. Just so that this is a proper unit test there. Oh, unless I can't count, which I'm not going to rule out at this point. Test filter, really? 1, 2, 3, 4, 5. Oh, not LST. I can count just fine, I just can't use the right variable name. Okay, and there we go. So this main purpose of this video was to run tests on our mutable DLL that we wrote last time and illustrate that it does indeed work, at least to the accuracy of the tests that we've written. As with the singly linked list, these tests are not exhaustive. There are more things that we could do. And I also wanted to show you the fact that when you use functions like filter and map, which produce new collections, because of the way that we did our inheritance here, just extending the mutable buffer, we wind up creating the same type that mutable buffer creates, which happens to be an array buffer. But that's it for this video, and we'll come back next time and we'll write yet another type of list. In this case, we're going to go for immutability, and we'll do a singly linked list.